So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. This week, we're talking about cost trends in the solar industry. Now, I'm happy to say that solar prices keep drifting lower. That's great for consumers because they're saving more money. It's great for installers and suppliers because their business is going to continue to grow. It's good for the economy because it's creating more clean energy jobs. I mean, currently, there's about 200,000 people working in the solar industry. That's way more than the coal industry, and it's more than the entire investor-owned utility industry in California, which is the biggest solar market. So it's a lot of employees, a lot of people, a lot of families making ends meet with solar. And it's great for the environment because renewables like solar are the best way for us to quickly deploy clean energy, and that's going to slow down global warming. But it's bad for incumbent energy utility providers like utilities. I mean, it's just a change in their business. They like to sell electricity and generate assets. And when people can generate solar on their business or their home, the utilities lose revenue. They're selling less electricity, like any business. And they also get a guaranteed rate of return from the utilities, public utilities commissions. And those guaranteed rate of returns in the utility industry are like 10 or 11%. They're based on the amount of generating and transmission and distribution assets they have. So the more assets that utilities have, the more profit they make. But the more assets they lose because people are putting solar on their roof, their profits go lower because they have fewer assets and they get like 10% on a lower number. So we're talking about big changes there. And these changes are inexorable. The cost trends for solar will continue to improve. And it's having impacts both on utilities, but it's also having big impacts on other companies in the energy industry. I mean, I've just been reading this week that the public coal companies, big public coal mining companies, are having a lot of trouble. Some of them are declaring bankruptcy. Now, that's not a good thing because there's a lot of people out of work. Hopefully, they can be retrained in clean energy. But the causes for these bankruptcies, it's not because of solar. It's not because of wind. Those energy sources are still a relatively small percentage of the generation in the U.S. It's because natural gas prices, a competing fuel to coal, are lower than coal prices. And natural gas is a little cleaner than coal. Still generates greenhouse gases, CO2, but it's cleaner than coal. And utilities are putting in natural gas plants instead of coal plants. And also, we're not manufacturing as much steel in the U.S., and when you manufacture steel, you use a lot of coal to fire those furnaces. So we're using less coal for steel. And finally, there are new environmental regulations which aren't prohibiting electricity generated from coal, but it prohibits a lot of emissions. And to control those emissions, the plants have to have added capabilities, added equipment, and that just makes generating clean power from coal more expensive. I like to say that you can get cheap coal, you can get clean coal, but there's no such thing as cheap and clean coal. I mean, that's just a law of thermodynamics, and unfortunately, we've got a lot of these coal plants that are finding that out. Now, for the solar industry, what's going to change over the next 5 or 10 years? Well, the trends that we talked about as far as costs coming down are continue. Electricity is going to continue to get more expensive. Our global warming problem is not going away. It's getting more urgent. We're finding out that the temperatures are rising faster than even what some of the scientific models indicated. So the problem's getting worse. And we're also, I think, going to start using more electricity per capita as we transition to electric vehicles as opposed to fossil fuel vehicles. And we transition to a lot of industrial processes and home processes using electricity. So heating from electricity is going to see more of a resurgence because it's going to be less expensive. We're going to have more air conditioning. So we're going to use more electricity per capita. Yeah, everybody should put in LED lights. That's going to slow things down. We've got more efficient refrigeration and home energy appliances, but we're going to be using more electricity just because it's a convenient and clean power source. And solar, luckily, along the way, it's just going to get cheaper. So there's no doubt in my mind that over the next 10 years, residential solar is going to come down in price to around $2.50 a watt. Now, right now in the U.S., it averages probably between $3.50 to $4 a watt. And let's just kind of using ballpark numbers, a typical home system's about 5,000 watts. So that's about $20,000 at $4 a watt. Well, I see definitely a situation where that cost for that 5 kilowatt system is going to come down to about $12,500. And that's before any incentives. So all right, heck, what does that mean? Well, let's do some really quick back of the envelope math. And you don't have to be in the solar industry to be able to do this math. It's pretty simple. $2.50 a watt, that's the cost of a system. And a typical system in many parts of the US is going to generate 1.5 kilowatt hours per watt of capacity. So we take 2.5 divided by 1.5, and then we say, all right, let's say the system's going to last for 25 years. And that's a pretty good number. There's not a lot of maintenance. If you have an inverter, an older inverter, maybe you have to replace it. It costs $2,000 or $3,000. If you have an inverter that's guaranteed for 25 years, really no maintenance. And we at Cinnamon Solar are certainly doing maintenance on old systems. The panels are almost always still working. So do that math, $2.50 a watt. 1 watt is 1.5 kilowatt hours. And we run this model for 25 years. That works out to solar on your roof. If you put it in at $2.50 a watt, no incentives, it's 7 cents a kilowatt hour. So you generate electricity for 25 years at 7 cents a kilowatt hour. Now, at the end of 25 years, the system's probably still going to work, so it continues. But that's a pretty amazing cost. That's less than utilities pay for their own electricity. That's way less. I'm in California here. I think I looked at my recent bill, and I have an EV. We're charging that thing up. I'm paying over 34 cents a kilowatt hour, so it's like 5 times cheaper. So what the reality is with solar, based on this cost trend, the costs of solar-generated electricity blow away any other generating source, especially when you consider that generation's done on-site, so you don't have a lot of the transmission and the distribution problems. What this means is that the utilities they can't compete. They're going to need to put in their own solar because it's still cheaper, but when people can put the system on the roof for cheaper than the utilities can deliver it, way cheaper, like by an order of 5, they can't compete. It's kind of like the post office can't compete with email. Technology changes. Yeah, it takes 10, 20 years, but how many first-class letters have you sent out over the last week compared to how many emails? And, go back 20 years. How many letters do you use? I mean, I buy a book of stamps almost like every year. The only time we use stamps are when we send out the holiday cards for the company. Anyway, so these costs are going to come down. And we're going to continue to see very steady growth in the solar industry. And let's just kind of take a look at what some of the numbers are as far as residential solar in the U.S. In 2006, there were 30,000 homes that had rooftop solar. And the average system costs was about $9 a watt. I was running a pretty good-sized national company at the time, and we were a little bit less than that. But those were kind of the early heady days. It was before the crash. Solar was growing nicely, but it was still expensive. And the reason why we were able to get those systems in is because there were big incentives, and those incentives really helped. Now let's just look what happened in 2014. I just got some data for that. In 2014, 8 years later, there's 400,000 homes with solar, and the average installation cost at the time, 2014, about $4 a watt. So it came down by more than half. And we'll talk about what factors drove that cost down. Now, 2016, we expect that there's going to be 1 million homes altogether with solar. And the current average installation price, so this is countrywide, that's cheap places and expensive places, is about $3.70 a watt. So it's a little bit less than 2014 and obviously way less than 2006. So residential solar's gotten pretty big. We expect to install in the U.S. 2 gigawatts, 2,000 megawatts. Put that in terms of the number of homes. That's about 350 houses, new construction and retrofits. 350 houses are going to get solar on the roof. And based on current trends, by 2020, there's going to be 6 gigawatts. And in terms of total industry size, that means that the solar industry, residential solar industry, is going to be a $20 billion industry by 2020. Now, there's going to be other big markets for solar, which is great. There's going to be the commercial and industrial segment, commercial buildings putting solar on those flat roofs, and tremendous potential for that. And obviously, there's going to be a lot of utility scale and even community solar where utilities are going to put the solar panels in themselves. But huge growth. And, by that time, 2020, 1 million people every year are going to put solar on their roofs, and I expect it to continue to grow beyond that. Now, but there's big variations in the industry on a state-by-state basis. Some states are cheaper, some states are more money. There's some interesting data from Energy Sage, and their average national estimate was $3.69 a watt. But what's interesting, Texas was $3.21 a watt, so much cheaper to install solar in Texas than the average. Here in the Bay Area, California, it's probably closer to $4 a watt. Now, why are these variations? Well, the variations happen all the time. There's competitive markets, but candidly, I don't think that the competition's really driving it. Just about every market that has solar ends up being competitive. I've never been in a market where there's only one company offering solar. Anybody who wants to put in solar can always look online and find a half a dozen, even in a remote community, half a dozen companies that'll put in solar. So there's lots of competition. But really the variation is caused by the cost of living and the construction costs in an area. So high cost areas where things are expensive, where houses are expensive, the construction's expensive. It's like any construction project. Texas is a relatively lower cost state. The cost of living is lower there. They also have bigger houses and bigger roofs, so you have economies of scale. So that's why naturally you'd expect to see systems cheaper in Texas. Now, the cost of the equipment in Texas is the same as the cost of the equipment in California or Vermont. But the installation costs, the soft costs, the business operating costs, and the scale of the system are going to be more favorable in Texas. All right, so I mentioned a little bit about the system size variations that cause this variability. Here's the reality. The larger the system, the less expensive it's going to be on a per watt basis. Obviously, the total cost is going to go up because you have more solar panels, more variable costs, more labor. But the cheaper the system is going to be on a per watt basis. Because on every single system, you have what are called fixed costs. You have the costs for marketing and sales and filling out a contract. And we call that in the industry customer acquisition. So when you're buying solar for your house, the guy that comes to your house and, he might make like 3 or 4 visits and it's a competitive situation. And he's going to have to do a design and contract. You got to pay him. And it's expensive to find the leads, to do the advertising, to work on the updated website to get that in. So those customer acquisition costs, fixed costs, you always have them. Every system has to be designed, and then every system has to be sent to an engineer to create plans for the building department. And then you need to get approval from the building department, get a building permit. Then on every system, you have to deploy an installation crew. They have to go there 1 or 2 days or maybe more, and they're driving their trucks, and it's just like a fixed cost of that infrastructure. And then every system, you have an inspection, you have interconnection. I kind of took a quick look at these costs when I was preparing for the show today. And I've been using the same installation costing model since 2001. Obviously, I've updated all the prices. But it's very easy for me to say, okay, let's look at the cost for a system, assuming that we're installing 0 solar panels, 0 inverters, 0 racking. What are the fixed costs? Well, the surprise is that the fixed cost for a system, for a residential installation company, it's over $5,000. And guess what? I would say at big companies, you might be looking at fixed costs, even if they do nothing. They don't put one panel on the roof, but they market it, they sell it, they contract it, they prepare for the interconnection, they do all the paperwork. Their fixed cost might be closer to $10,000. Little guys are probably going to be less. So when you have that fixed cost of, say, $5,000, the bigger the system, the cheaper the average cost is, because you're going to spread those fixed costs out over a bigger number of panels, over a bigger system. Now, other factors that really have changes when you're looking at solar for your house, and when you're saying, why is my system more expensive than somebody else's, or how can you get it less? One of the big factors is the roof type. Composition shingle roofs, those flexible asphalt shingles, they're by far the cheapest. And clay tile and slate, you have slate on the East Coast on those steep roofs, and then you have clay tile. Some of the older houses have that barrel clay tile. Walking on clay is like walking on potato chips. They just crack all the time. So they're very, very hard to work on. Slate is very tough too because it cracks. So when I go back to the costing model, the difference in the cost for a typical 5 kilowatt system for clay tile, it's $3,000 more. $3,000 more than a composition shingle house. All right, now let's talk about things like equipment variations. Now, you can get equipment that's cheap and less efficient, maybe not from a brand name company, or you can get more expensive equipment from a brand name company that's going to be more efficient usually. And so basically you pay more for more efficiency for a bigger brand. So solar panels, the most efficient panels, they're going to cost more money. Panels from big companies, they're going to cost more money. Same with the inverters. If you get an inverter that has a lot of features, or microinverters that have fancy monitoring and long guarantees, or inverters with integrated optimizers and wireless communications, that's going to be more. Or you can cheap out and get inexpensive, unknown brand name panels, maybe from an overseas manufacturer you never heard of. And you can get really stripped down basic inverters. And, the cost difference is you're going to save thousands and thousands of dollars on your system. Now, you may not get a system that's going to perform as well, and you may not get a system that's going to have as solid a warranty, but it's going to be cheaper. And I'm always talking about economics, because going way back, even 15 years ago, the solar industry really started to grow when economics got good. It's all about economics. And so you kind of look around the country and you see, where is solar going to be economically favorable? It's going to be in places where the economics for solar are great. And there are three factors, and it's only three, that they're the main factors. These are primary factors that dictate the economics of solar for you as a homeowner or for a company that wants to get into the solar business. There's just really three major factors. One, electric rates. If you're in a place with high electric rates, or if you pay high electric rates because you use a lot of electricity, with tiered rates that we have in California, solar makes more sense if you pay a lot for electricity. Hawaii, California, New York, high electric rates. So the solar industry is pretty good in those places. And the rates keep going up. It's amazing to me that the utilities are putting in big solar farms in the desert. They're generating solar for like 5 cents a kilowatt hour down in Texas, and even less. But the rates keep going up. Now, second factor, which is a real big factor, are the local incentives. So some states, some utility districts have very good incentives for solar. They could really make solar more favorable. And there's some places where there's no incentives at all. California, no incentives. Don't need it because the economics are already pretty good. Hawaii, no incentives. So in those places, if the incentives are high, then the economics are better. And the third factor, which is not as big, but it's interesting, is just the amount of sun. There's, looking at the variability between two different cities in the U.S. with sun, Phoenix has an average 7.1 hours of peak sun per day. Boston, Massachusetts, 4.3 hours. So if you put in the same size system in Phoenix, it's going to operate, like 60 or 70% more efficiently than that same system in Boston. You're going to generate more electricity in Phoenix than in Boston. But the economics in Boston are still pretty good because there's some state incentives. Now, what's going to happen with these incentives and these costs over time? They don't all change at the same rate. So, there's a lot of moving parts. There's up, things go up and down. What changes, what doesn't? Well, let's look at some of the major cost factors. The solar panels, heck, in 2004, they were $4 a watt. They're probably going to be 50 cents a watt in 2020. Right now, they're 65 cents a watt or so in large quantities. That's like a container load. A small installer is going to pay more. Big installers are going to pay even less than 65 cents a watt. So those costs are coming down. But interestingly, the efficiency keeps going up, and always the higher efficiency panels cost more. In 2006, the average panel size was about 170 watts, and it was 14% efficient, and they were about $3 a watt. Well, 2016, the average panel size is closer to 270 watts, way bigger, 100 watts bigger. And the average efficiency is 17%. And we're looking at costs of around 65 or 70 cents a watt for those medium or high efficiency panels. And higher efficiency panels cost a lot more. So here's, and we're looking at the factors of other things like inverters and racking, and then we're going to get into the labor in a sec. But here's the non-intuitive thing. And even people who are kind of in the solar industry but not on the installation side don't really encounter these numbers, and it's surprising. And people who aren't in the solar industry or just thinking about getting solar for their house without doing a lot of the research, they're just surprised at these. But here's the thing. The cost of the hardware, the panels, the inverters, that keeps going down. But the other costs aren't coming down as fast. In some cases, they're going up. So here's an example. Do-it-yourself solar. You can buy a kit online of solar panels, inverters, and racks. That's about it. You're going to have to scrounge up everything else. If you do it yourself, you're also going to need to do, in addition to the installation, the design, the engineering, get the permit, the interconnection. You're going to need special tools to crimp the wires. You're going to have all these tricky little parts that you may not get. It's complicated. So if you do it yourself, there's no customer acquisition costs. You don't need extra insurance. You don't have to pay for trucks and gas. You don't have overhead. You don't have employees. So they can be really cheap. It's going to be a big hassle, but it's like any do-it-yourself home improvement project. You want to redo your bathroom? You can do it yourself too. And it's going to be a heck of a lot cheaper than if you hire a contractor. But most people aren't going to want to do it themselves. So let's look at what some of these future trends are for these cost reductions. And, it's pretty clear to people who have been in the industry a long time, you kind of get a good idea from what happens historically, and things don't always run smoothly. But the cost of the panels, they're going to continue to decline. The cost of the inverters, it's going to continue to decline. The mounting systems that you use on your roof, those costs continue to decline. And the cost improvements are usually because of two things: new technology that makes it cheaper, and then just mass production. Every time you double production, you might reduce costs by 5 or 10%. So that just makes a big difference. And there's also going to be a big reduction in the financing costs. Financing solar 10 years ago, really expensive on a home. Even 5 years ago, the when you look at the total cost for a leased or a PPA system, really expensive compared to the cash system. But now there's a lot of options. So those financing costs have come down a lot. So great improvements on these hardware and financing costs. But you know what? There's other cost factors that are not going to go down. In fact, in many cases, they're going to go up. Customer acquisition costs, the marketing, the sales. You look at the data in the solar industry, it's actually been creeping up. We hope it goes down, but it's been going up. Lots of factors for that. I'm not going to get into the details, but it's not getting cheaper to find a solar customer. For many of the big companies, it's actually getting more expensive. Smaller companies can find customers relatively easily because they're based on referrals, but you don't get a lot of referrals that way. You're not talking about big companies generating business on referrals. Other things, insurance. Insurance is a one-way street. It always goes up. So the insurance for solar is going to continue to go up. Labor costs per hour, that's going to go up. We're paying people more per hour. There's minimum wage requirements. And I'd say almost all the solar companies are already paying their employees much more than minimum wage. And now the labor total costs may get better or may stay stable because the installations are more efficient. But those costs, they're not going to get a heck of a lot better. Things like incentives, it's hard to say. The federal incentives, the investment tax credit, that's going to go down in 2021 from like 30% now to zero. State incentives, state by state, lots of variability there. And there's also lots of variability with the net metering. So although electric rates keep going up, there's some places where the allowable net metering rate, in other words, the rate at which you can run your meter backwards, is getting worse. Now, what does this mean for solar installers? Well, it means that there's going to be changes in business models. I think this industry is going to continue to evolve. I believe that the industry is going to look a heck of a lot more like the HVAC and the electrical contracting industry, where the equipment's relatively cheap, but there's just a heck of a lot of work, of overhead, of labor, of permitting, of engineering to put in the system, and that ends up being a big cost factor. There's going to be companies that just do installations, and there's going to be companies that just do sales. So instead of an integrated local company or an integrated big company, there's going to be specialist installation companies and specialist sales companies, and we're seeing that now. Now, what does that mean for consumers? You're thinking about solar for your house. You're listening to Barry talk about all these details. Well, what that means for consumers, the cost will definitely come down. But this is my advice. It's 100% objective. My suggestion is, and this is very sincere, you should look at buying now, not later. And the math is really simple on that equation. The cost declines in the solar industry are going to be and continue to be much less than the annual savings that you would get. So let's say, just round numbers, the total system costs come down $1,000 a year. But let's say with a system, you're going to save $2,000 a year. You come out $1,000 ahead if you buy now. Yeah, if you buy it next year, it's going to be a little bit less expensive, but you just blew $2,000 on electricity. So every single customer that I've sold to since 2001, all over the country, they're happy they bought solar when they did because they've been saving electricity the whole time. Yeah, plus they get the environmental benefits. So it makes good economic sense to install solar now on your roof and put a bigger system in. And just because I know that your electric usage is going to go up with EV and more home HVAC. Anyway, covered a lot of territory. That's all the time we have on this week's Energy Show. Thanks to all of our listeners for joining us. And if you missed any of today's show, you can always go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.